Good day, Professor Addison and fellow classmates. My name is Patrick Caze. Today I'll be presenting my final project for Computer Vision AI 521. So first off, we want to talk about what is computer vision. So computer vision is an area of AI that tries to facilitate the understanding of digital images by computers and systems so that we can garner some type of information from the image that's being displayed. Computer vision is used in a variety of applications to include computer games, movies, retail, law enforcement, and many other industries nowadays. So for my, excuse me, for my project, I used 317 images of my niece and nephews, Layla, Mason, and Max, that you can see here respectively. I didn't do a lot of pre-processing on the images. The images I received were given to me by my sister, and she had taken the pictures with an iPhone for the most part. So the images were of decent quality and provided a lot of different poses, not to mention variation in lights and background and a lot of things that you'd want to have in your image as far as blurring and occlusions and things of that nature. I did apply Gaussian blur in some instances when I was doing the cartooning and the face recognition algorithms. I did also do some shearing and some horizontal flips just to give my data set some different dimensions and some different things to look at as far as the algorithm went, so that it would just give me a different understanding of how the algorithm worked, and to see if the algorithm could work under in most, if not all, situations. So the first thing I did was the face detection. All right, face detection is a computer vision technology that assists in locating or visualizing human faces in digital images and videos. Okay, and so the algorithm that I used was basically the Violet-Jones algorithm, the hard cascades. The libraries I imported were CV2, NumPy, and Matplotlib. Now, going back to the Violet-Jones algorithm, the hard cascades basically use object detection, for face detection using edge line detection features. So the way that the hard cascades work is that it uses a rectangle and it starts from the upper left corner of the image and it traverses the image until it gets to the point where it identifies or detects some features of a face. Normally starts with the eyes, the iris, moves on to the nose, the mouth, and so forth and so on. Once the first rectangle has decided or figured out there's some features that are attributed to a face, it will then hold those features, and then the second rectangle will begin to scan the next area that is up in the image. And so the hard cascades was one of the first really widely used algorithm in face detection. There are other algorithms out there now that are a little bit more robust, but the hard cascades remain one of the favorites being used in face detection algorithms. If we look at the input image, of course, it's of Layla, Mason, and Max. Nice color, RGB. Then I turned it to grayscale, converted to grayscale because that's how CV2 is expecting the image or the input image to look like. And then you can see the output image, the rectangles are depicting the detected faces. So all in all, the algorithm worked pretty well. In most cases, there were some instances where the algorithm did not perform as well, just because I think it worked well with frontal views, and not necessarily images that had people that weren't facing directly into the camera. So the one image that I used to test it had 5 faces in it. 4 of the 5 were detected, but the one that wasn't detected, I observed was looking at the camera at an angle, so it did not get detected by the algorithm. I know that there are ways in which to remedy that, but all in all, I still felt that the algorithm worked pretty well. The hard cascades and the feature detection using the edge technology and the edge and line technology, technique worked fairly well. The next thing that I did was image transformation, or I wanted to apply a cartoon effect to the image. So cartooning is just a technique that transforms the image into a cartoon drawing. Many times you'll see this in fairs and that kind of thing, but it's normally someone drawing caricatures or someone sketching and that kind of thing, right? Comic books, of course. But it was interesting to me to see how I could use the technology, the computer vision technology, to do the same thing, because I'm not an artist, but I do like to, change up the appearance of my images. And I thought that my niece and nephews would find it interesting. So for the algorithm itself, the libraries I imported were CV2, NumPy, Matplotlib. And for this particular process, I did do some pre-processing. Specifically, I did a Gaussian blur. And in doing the Gaussian blur, basically the pixels nearest the center of the kernel are given more weight than those far away from the center. And the Gaussian blur really is used to remove detail and to reduce noise, right? I also use adaptive thresholding, and adaptive thresholding is the value that's calculated for smaller regions, producing different thresholds value for different regions. So basically, you could use a normal threshold, but that normal threshold is global. So because it's global, it would be applied to the entire image and would not change based on the pixel intensity within that area. So what the adaptive thresholding does is that it stays in that local region and it calculates the threshold value for that local region, and then it changes based on the local values for those areas. And so it gives you a better result. So the next thing that was done was that I got an edges image. As you can tell, came out pretty good. Could have been a little better on Layla's hair, but if you look at the original image, it's somewhat, because of the way the light kind of bends in the color of her hair, it kind of vanishes, right? And so all in all, still not too bad on the edges image. I thought it went pretty well, right? Then I used that to, do the cartoon image, of course. The cartoon image came out extremely well. I was very happy with it. And then I decided that I wanted to do a blur and also a cartoon together. And so I, again, applied the Gaussian blur with a medium blur, and also looked at using a edge preserving piece of code so that I could get really defined edges for my image and for my cartooning, right? As you can see, the blurred cartoon image, it looks a lot smoother, less detail, which is what I was kind of hoping for using the Gaussian blur. And if you compare the two, you see that the algorithm worked pretty well based on what I had inputted and what I had used as far as some of the techniques. So overall, I was pretty impressed and pretty happy with the outcome. My niece and nephews thought it was really cool, and they actually were interested in trying to do other things to the images. The last thing that I did was a face recognition. And face recognition is technology that is able to match a human face from a digital image or video when compared to a database of faces. Face recognition is used by many different entities and industries. You can find it specifically in iPhones, right? And people now can use your face to unlock the iPhone. And so that was something that Apple had incorporated in 2017 for their phones. And now it's pretty standard across the board for all their newer model phones, right? Face recognition has also been applied and used in law enforcement, retail, and a number of other different industries. For the algorithm libraries that I imported were TensorFlow and Caze. And basically, Caze is built on top of TensorFlow for the face recognition model, and it's widely seen as one of the better, or not better, but one of the most widely used modules for face recognition, right? And for the model itself, I, of course, decided for a convolutional neural network, as that is probably the best way in which to build an algorithm for face recognition. It has proven itself to be extremely useful. I use a sequential model. So basically, I had my different layers as far as the node, input nodes, hidden layers, and the output layers. But in order to lay or to have as many hidden layers as I would like, I used a sequential model. I did 10 epochs, right? And for the activation, I used the ReLU, right? The rectifier linear unit function. And for the cost, I used the softmax function, right? As far as the loss goes, I used the cross entropy function or technique. And I also use the accuracy as far as the metric to figure out how wrong, or to keep track of how wrong my model was. I ran, as I said, 10 epochs. After the 7th epoch, I reached 100% accuracy on the trained model, which I was pretty ecstatic about. And it was pretty fast. It went in about a minute. As illustrated in the next slide, you'll see my screenshot of my epochs and them being run in the accuracy percentages that were attained. So in order to test the trained model, I decided to use this unseen picture of Layla, as you can see up here, and put it into my trained model. And so as I put it into my trained model, it successfully identified the picture as Layla. So I was pretty happy about that. The additional test that I did with some other images didn't turn out, that great. So I had tested it with another image, and it didn't recognize the image as it should have. It identified it as Mason when it really was not Mason. It was me. I had submitted a picture of myself. And so I believe that although the accuracy of the trained model is pretty high, I think that because of my small data set and the fact that I had to copy some pictures to increase my data set, there might have been some overfitting done. Also, I believe that if I had different more pictures with different poses and also implemented more epochs, I think the model could be trained better and to a higher degree. And I think that would, again, result in better predictions for my model down the line. So with that said, that's all I have for my project. I'm happy that I got to share a little bit about what I did for my final project. And I look forward to your questions and comments, and I look forward to also reviewing your video presentation on your particular subject. All right, thank you. Have a good day.